fantastic day, everyone. I'm going to run a chaos experiment live on production. Yeah. Usually people don't run anything live because they are afraid that something might go wrong. But in our case, I actually want something to go wrong. Dear gods, please switch to the live coding. Oh, thank you. That's fast. Yeah. Okay, so this is one of our experiments. I'm just gonna change it to full. Thank you. And build. All right. Gods, please switch back to the presentation. Absolute professionals. All right. So, my name is Leo. I'm a tech lead software engineer at Wix. I currently in a team called Chaos Hub. Shout out to my boys. I like to produce music on my free time. I like to live my life and do whatever I want. And I'm glass half full kind of guy. So what is chaos engineering? When you deploy something on production and it accidentally breaks half of your system, that's called, well, I'm fucked. But when you do the exact same thing but on purpose, that's called chaos engineering. Generally speaking, chaos engineering is a way to test if your system is resilient and strong enough against any problem or incidents that can occur. And I forgot to press the buttons. Why do we need it? We need it to identify a weakness in the system through controlled experiments. Whenever we run the experiment, we want to make sure that the system is still working as it should. If something bad happened during the experiment, we return everything as it was before, we write down the issue in order to resolve it later, and make sure that this issue never happens again. We also want to connect lots of metrics, such as traffic rate, error rate, and everything that in theory this experiment would affect. And we want to increase confidence in our system by finding out all the problems and making sure that there's an automatic mitigation to those issues. Currently at Wix, our team is responsible for maintaining and developing our case framework. We also provide mentoring and support to 4 teams that are responsible for different parts of the system, and they have created 11 chaos experiments in total. And we teach them all about chaos engineering culture. Now, what is chaos experiment? Chaos experiment is an automated set of steps that injects chaos into the system. In order to create a chaos experiment, you need to understand what kind of chaos experiment you're going to do. Let's say our system has 10 servers up and running, and they are communicating with each other. Now, what's going to happen if we will emulate that one of those servers will suddenly die? Let's do exactly that. After that, we need to define a steady state. A steady state is a set of probes or functions that would check that your system is currently steady. For example, having 10 servers up and running could be a steady state. Additionally, we could have some metric like error rate, and we would expect 0 or a very low amount of errors. Click on the button. Damn buttons. Okay. That was steady state. Yeah. Anyways. Then after that comes the actions. Actions are actually destructive functions that would actually kill the server. After the actions are completed, then comes the steady state again to make sure that the system is still steady. And 1 sec. Is it running? Okay, thank you. Then, 1 second. Okay, so then runs the steady state again to make sure that the system is still stable. That means if we kill a server, then some service like autoscaler or whatever should bring this server back up before the steady state launches. Then comes the rollback. It should clean up everything you've done with the system. For example, if the server didn't relaunch, that means there's a weakness in your system and that you should resolve it later. But for now, this rollback should bring this server back up. Now that we've understood what chaos experiment is, we can start understanding what the hell did we run in the beginning of this talk. Quite a while ago, we've decided to create our first experiment on our network. Whoops. The buttons are broken. Okay. I'm just not going to use the remote. Yeah. All right. Quite a while ago, we've decided to create our first experiment in our network. All Wix stand on 12 legs, 4 data centers and 3 legs each. Make sure that you imagine robotic legs and not the real ones. You'll understand why later. Every minute in all the data centers totally goes through about 500 gigabytes of data. Now imagine what's going to happen if we will cut one of those mechanicals' leg off. PETA, please don't sue me. Those are robots, no animal cruelty happening here. And that's what we did. We called it ISP link down. ISP, as you know it, is a local internet service provider, the one who gives you the ability to serve the internet. In our case, those are tier 1 ISPs that provides connectivity to the data centers. ISP link is a physical port in the data centers that allows the connections to go through. We emulate a physical failure of one of the ISP links by picking a random data center, click, okay, picking a random ISP link on that DC, and disabling it. Then we wait a few minutes, and then our steady state checks that it didn't have any impact on the users, and that the total gigabytes inbound and outbound metric didn't decrease much. And then in the rollback, we bring this ISP back up. What benefits did we get from it? Whenever multiple people try to connect, try to change the configuration of the ISP machine, it will create conflicts. And the last person that committed the change would override the others. And we resolved it by simply allowing only one person making changes at a time. We also found out that every time we disable the ISP link within 50 minutes, there's a time penalty of initialization of the link, which means it won't start up for a specific amount of time depending on the penalty. We found out that we are missing some panels, so we've added total ISP link utilization, total requests per minute, and more. Because of this experiment, we have the confidence that if there is an issue with some ISP link, we can always disable it and know that it won't impact the system. And we understood the system much better this way. And I forgot to press buttons. Nice. In the beginning, we couldn't just take the ISP link and kill it. That's because we were lacking confidence in our system. Therefore, we've added a lot of safety measures that would decrease the blast radius of the experiment. A blast radius is an indication of how many services and how big the impact is from the experiment is going to be. Our team have provided 2 more steps to the chaos experiments: pre-checks and smoke detectors. A pre-check contains probes that checks things that aren't necessarily caused by the experiment. It can be something like, make sure that there's no DDoS currently going on, or make sure that there are no sales currently going on, and etc. Smoke detectors would perform the same types of checks, but in parallel to the destructive actions. They will be executed every few seconds. So if during the experiment there will be a DDoS attack or some other problem, then it would stop the experiment immediately. Then after we finish the planning of the experiment, we schedule a meeting with the whole team in order to review this plan. We call it technical plan review. We've collected the feedback, found out where and why this could be problematic and how to solve it. We've created action items and solved all of those issues in the system before we run or even develop the experiment itself. After that, we've started the development process. And when it was close to be finished, we scheduled a risk assessment with all the relevant people and the owners of the part of the system that we think that this experiment would affect. We make sure that everyone in the system is ready for such experiment, and we get their approvals. Now we have our experiment well planned, developed, and even executed a couple of times. We are ready for the next step. The next step is to increase the blast radius. So we sit again with the experiment owner and make a plan on how to do that. For example, one of our pre-checks contains a probe called make sure that there's no DDoS. So in order to increase the blast radius, we can eat that pre-check out of here and have the experiment run even if there is a DDoS attack happening. That's just one of the examples that would increase the blast radius. We would make a whole list from a list of those from less dangerous to the most dangerous experiments, up to killing a whole data center one day. And we're doing those slowly, one by one. Therefore, the system gets better every time. All right. Let's take a look at the experiment we ran in the beginning of this talk. And gods, please switch to the live view of the coding. Oh, that's on me. I need to turn on my computer. Thank you. One sec. Okay, there we go. All right. So we have this Slack channel. If you want to see the Slack channel, you can join the Chaos Hub experiments. Thank you. So this is the last experiment that we run, executed by me. We have graph analogs and pre-checks. We talked about pre-checks. We selected DC11 randomly. Great. And there is one of the pre-checks. We have here the DDoS attacks. After all of those pre-checks, we have the gigabytes inbound and outbound, just to make sure that there is no significant decrease in those. All right, and then all the way down to the actions, we have tag a random ISP port, and then deactivate that ISP port. All right, we deactivated, waited for 180 seconds, and run the steady state again. All right, and then in the rollback, we activated the ISP link back up, and looks like the system is strong, and blah, blah, blah. It's a disappointment. I really wanted to break something today, but okay. Gods, please switch to the presentation. No answer. Thank you. Absolute professionals. All right. Now that we've saw the experiment in progress, we can talk about the postmortem that happened recently. Do you remember we talked about 3 legs per DC? A leg is the ISP link. Okay. What happened is one of those ISP links had some problems, and it was on maintenance. On the same ISP link, there was a DDoS attack. However, that DDoS attack was weak enough to not trigger any of the smoke detectors. So our smoke detectors didn't think that there was anything wrong, so coincidentally, Chaos Experiment chose the 3rd link and shut it down. So we've had 2 ISP links left. Both were under a DDoS attack. Our experiment highlighted the link with the issues, and it created some unexpected user impact, mainly affecting Wix answers and user manager. Now, oops, sorry. Because why did we choose this experiment? because ISP links can die naturally. And we don't want the same situation that happened with Facebook recently to happen to us. That said, other than the ISP links, we have plenty of more. We have overloading memory in kube nodes, killing varnish cache services, killing dispatchers in the micropubs, killing vault instances, killing all mesh-related pods, and more. The future of chaos is to get to the biggest blast radius and hopefully kill a whole data center. And set up out-of-the-box chaos experiments for every single artifact. If you're interested more in chaos engineering and you want to get more details, you can contact us through our Slack channel, Chaos Hub. Hell yeah. And that's it for now. Do we have... Thank you.